Hallo. Grüß euch und willkommen beim Technologieplauscherl, dem 90. Technologieplauscherl. Danke. Gleich vorweg einmal ein großes Dankeschön an die Ubitec, dass wir da sind, und ein großes Dankeschön an euch, dass ihr so zahlreich erschienen seid. Das ist schon mal ein richtig guter Start ins neue Jahr. Und genau, Modus heute ist so wie immer, 2 Talks, dann eine Pause mit genug Getränke und Essen und dann die Community News und noch ein Twitter-spannender Talk. Genau, damit das Wichtigste haben wir vergessen, wir haben eine Verlosung heute für RubyConf-Tickets. Wer ist da für die RubyConf-Tickets? Hände hoch. Gut, ich glaube, das werden wir dann nach der, oder in der Pause zwischen euch zwei auslosen. Kurz zu euch nur, are there any English only people here today? Okay, 1, 2, 3. Well, good news and bad news. There are 2 talks in German today, 1 talk in English. Okay, 2 talks in English, 1 talk in German. 3 talks in English. Awesome, great community. And with this, I hand over the mic so that you can learn something about Ubitec. Thank you.
Hallo, herzlich willkommen auch von Seiten Ubitec. Wir machen das, glaube ich, jetzt das 3. Mal, wenn ich erzählt habe. Wieder volles Haus, das freut uns sehr. Ich möchte es auch gar nicht zu lange in die Länge ziehen. Toilette hinten in der Küche, in der Ecke angeschrieben. Und es gibt beim Eingang vorne noch ein kleines Gewinnspiel. Das heißt, irgendwer wird eine Kugel ziehen, wo ein Ubitec Goodiebag drinnen ist. Der meldet sich dann bitte bei einem Ubitec-Mitarbeiter, der vielleicht erkennbar ist oder auch nicht, der wird einen finden. Dann wünsche ich euch noch viel Spaß am heutigen Abend und schauen wir Folie. Schauen wir uns mal Folie an. Ah, genau. Und für dieses Wettbewerb dann Getränke stehen zur freien Entnahme herum. Essen kommt dann in der Pause. WC habe ich schon gesagt. Und Notausgang ist dort, wo ihr reingekommen seid. Ich glaube, das war's. Das ist das Referenzfoto, wenn ihr Ubitec-Mitarbeiter sucht. Und wie gesagt, die Verlosung stellen wir wieder vorne auf den Tisch. Ein paar haben schon versucht zu öffnen, 2 Versuche sind verboten. So, jetzt da.
Hello. Yeah, okay. That seems to work. Can the people in the back hear me well as well? Yes. Cool. Okay. Okay, then let's get started. Hi, hello everybody. Welcome to the Technologieplauscherl, and I will be speaking today about Postgres, about how to use Postgres as a message broker, and why we replaced our RabbitMQ cluster with Postgres. So just quickly to get this out of the way, that's how I look on the internet. My name is Martin, I'm an engineer here at Ubitec. I have been doing Linux and web dev stuff for around 20 years now. I really like backends, databases, DevOps, Linux, infrastructure, all that jazz. And if you still do the social media stuff, I'm on Mastodon and Blue Sky and LinkedIn. Alright, let's get really started. So, who knows what a message broker is in the context of web development? Okay, half. Yeah, okay. let's get everybody at the same level. So what is a message broker? Usually we have some parts of code that send messages, and then we have some other parts of code that subscribe to those messages, and then they receive the messages and do something with it. And the message broker is the thing that's in the middle of it, and that the broker's goal is to coordinate this flow of messages. And it coordinates the publishers, the subscribers, it manages the messages, it makes sure that every message is only received once, or that the message that every message that is in queue is actually received by somebody. So it also keeps track of who subscribes, all those things. Usually the data structure behind this is a queue. It's implemented as queue. FIFO, maybe you remember that from your school classes, first in, first out. So whatever comes in first gets out also as first. So it's a queue. I write here usually because it's not really always the case, but most of the time. What do we use that for? Mostly we use it for stuff that is happening outside the normal HTTP response, request-response cycle. So whenever I need to maybe talk to a third-party API or do something in the background, that is usually where these message brokers come into place. And some examples for those is RabbitMQ, which is what we still use. Redis, there's also cloud solutions like AWS Express. There's Kafka, which I've never really used. I've heard it's way more, but you can also use it as a message queue. And yeah, so what do we usually expect from such a message broker? We want to have multiple queues because we want to partition the work that we do. So we want to partition it into multiple topics maybe, or different priorities, or different hardware, whatever. So we need multiple queues. We also want to allow multiple consumers. So there must be not only one consumer connected to a queue, but what if we get way more requests? We want to be able to attach more than one or even more consumers to the queues. Obviously, we also want multiple parts of code to be able to publish into that queue. We need to keep track. I mentioned it before already. The broker needs to know which messages have been sent, which have been received, which ones have never gotten an answer. Like all of that kinds of stuff needs to be managed. Obviously, we also want to manage the queue itself. So we want to create a new queue, or maybe delete the queue, or maybe empty all the messages because we know we had a bug and now we have 1 million messages in the queue, and we need to get rid of them before the normal processing can work again. No persistent data storage-ish. Many of the queues don't really store the data. So RabbitMQ, for example, you enqueue a message, it gets delivered somewhere, and then it's basically gone. Ish. Why ish? Because it's not so clear-cut. Some of the queues can store data. There's also result backend. Some have explicitly the feature that you can get the result of a message and then put it somewhere. So ish, but many of them don't persistently store the data. And they are optimized for high throughput and deliverability, and also I'm missing the word. Anyway, that's just the high throughput. Reliably, they must be reliable, of course. Every message must be processed. What does high throughput mean? I checked before this talk. I checked out one of the bigger RabbitMQ cloud providers, and on the highest tier, they guarantee you delivery of up to 500,000 messages per second. So it's really highly specialized software. Okay, so much for message brokers. Now, before I can jump into what we did, I actually need to explain a bit what we do here at Ubitec. So just a little introduction what we do, what is one of our products. So what we do, one of the products we make is what we call the AI portal. So we built for our customer, one of our customers, they want to run large language models, but on-premise. And we basically build everything they need to do that. So right on the left, right from your perspective. There's somewhere in the data centers, they are running large language models, and but with them like machines with big graphics cards, obviously. And to be able to access them, we built a layer in between, which is what we call the manager. And the manager basically exposes an API for actual applications that are on the left that use the APIs provided by the manager to do inference on the large language models. And obviously the large language models are the most expensive part of this whole operation. So the access to them needs to be fairly distributed between everybody who is using them, right? So we have a queue, a RabbitMQ queue, and first in, first out. So whoever comes along first will get the first response to this model, and then we'll receive the answer and so on. But that's not really enough because we wanted the different applications to have basically a budget that they can use. So to make it really fair. And so we thought, okay, let's just implement that with RabbitMQ. RabbitMQ has priorities, so it's not really FIFO, because you can enqueue messages with a higher priority, and then they will just be delivered first. But this didn't work for us, because let's say this airport or this application enqueues 5,000 requests, and after the first request, the budget is over. Then there are still 4,999 messages in the queue with the highest priority, and that is the thing that we needed to prevent. So as soon as the budget is over, we need to reprioritize all the messages that are in the queue. And with RabbitMQ, that's just not possible. The only way to do that in RabbitMQ is to put out all the messages and then enqueue them again with the new priority. And that's not really something that you can do all the time, right? So yeah, that was our what we needed to accomplish. So too long didn't listen. We need a queue that's not really strictly FIFO. But you know what's really great? What's a really great software if you have large amounts of data and you need to change much of this data in a really orderly fashion. What's really great at doing that? Yeah, good old databases. So we researched a bit and thought, hey, maybe we can just implement that using Postgres, which we already use. So if we do that with Postgres, what would we do? We would just use a relation to store all the messages. The queue is now nothing special, it's just another column, right? So is the status of the message. We just stuck with the lingo of RabbitMQ, so a ready message is something that has not been worked on, that is free for grabs for any consumer. We have unacknowledged messages, those are currently being worked at. We have acknowledged messages, those are done and finished. We have the priority, that's the most important one for us because we need to change it. We have the enqueued at, which is also important because probably our query for, hey, we need the next message will be something like the oldest message with the highest priority, right? So we also need the time when it was enqueued. And we need the tenant ID, which is like basically what we had before on the left, the application, so that we can downgrade all the messages of one of our applications. And then it will look something like this. So with a queue, the queue is always for a model, for a large language model. Then we have the status, which is like, is it being worked on or not? We have the priority, we have the time, which is just a timestamp that's going upwards, and we have some payload, the tenant ID string. So, yeah, cool. What else? Well, what's next? What we need? The software we use to basically schedule and manage our asynchronous task is called Taskic. I haven't mentioned it yet. So we have a Python backend. So we use Postgres, Python, and Taskic for our asynchronous task. Something, if you're into Python, like Celery or Dramatic, there's many of the, I think Django has, no, that's Rails. Django has something with job. Yeah. Anyway, Taskic is a pretty new library. It's pretty great. Everything is asynchronous, everything is async. And it has a really easy way to attach custom brokers. You just inherit from this class, and then you just add two methods. One is called kick, and kick adds the thing into our data structure. So in SQL, it's just an insert into. Thanks. And we have listen. That's basically an infinite loop that just reads constantly from this table and then prepares the message for so that Taskik can work with it. So let's look at some code. Word of warning. So for one thing, this is Django code. So this is Python. Python looks like pseudocode, so everybody can read it, right? This is Django. So if you ever use the web framework Django, this might look familiar. I will explain anyway. And the last warning is the code is not completely complete, so I stripped out some things. So before you see any mistakes, they're probably there just to make it short and easier to understand. So anyway, that's our listen. So what do? We have an endless loop, and on every iteration we just do object filter, state ready, filter by queue name, order by priority included, and first message. So that's basically select all the tasks that are ready, ordered by priority and included, ascending, both ascending. So we get the next message. If there's no message, we just take a break because we don't want to hammer our database. And what do we then? We set the task to unacknowledged because now somebody is working on it. We set some timestamp, we save it, and then we pass it on to our actual workers. Cool. One thing. Oh, I forgot. Yeah, here, that's maybe interesting. That's act task. What does this do? Because when the message is finished, we need to move it from unacknowledged to acknowledged. So Taskit expects this as a function. So act task is like a function generator that creates us the function which just fetches the task again and then sets it to acknowledged. And now the processing is done and Taskit calls that for us. All right, cool. So we're done, right? So everything that's like not really visible, like transparent, this are the messages that our broker doesn't see. So we only see the ones for this queue, and they're ordered by time. So obviously the consumer is going to fetch that message. Great, we're done, right? No, there's one thing, because what if the pink arrow is another consumer? So now two consumers pick the same message. Well, how did that happen? We have a subtle race condition in here, because there some time can happen between this line and this line. And if both consumers come at the same time and both fetch the task and both set it to unacknowledged and both save it, both receive the message, and that just sounds like trouble, right? It's also really shitty bug to happen, because usually in development I only have one consumer, right? Because I'm just in development. So it will probably only bite you in production, and then it will also not always happen. It will only happen if multiple consumers are close enough to each other so that they actually run into this problem. But we're using a relational database, so there's an obvious solution, which is select for update. So we can just put a lock, right? We use locking. So the first consumer comes along, he locks the row, and the next one will just grab the next one, right? Let's take a look again. Here's our first consumer. He fetches this one. He puts a lock on it, and now what happens? Nothing happens. Well, not nothing, but it first sets it to unacknowledged, and only then the next consumer comes. Why is that? Because if there's a lock on a row, every other connection that wants the same row cannot grab the row, right? It will either time out or throw an error. Both is not really acceptable. So the second consumer just waited until the first one was done, and only then grabbed the next one. So cool, we don't have a race condition, but now we have serialized access to the queue at this little piece of code. So that's also not great. So Postgres has an answer to that, and that is skip blocked equals true. So skip blocked does exactly what it says. It will it will just skip all the rows. It will make the query skip all rows that are already locked by some other process. And now everything pretty much works out. Because now the first consumer comes, he receives the usual message, he locks it, and the second one, now it's immediately invisible to the second one because of the skip lock. See, it's transparent. While the status is still on ready, so we didn't move the message from ready to unacknowledged, and already it's no longer visible to the second consumer. And the second consumer can immediately pick up the next one, which will then lock and so on. Cool, great. So we're done, right? Nice, we have a Postgres broker, all problems are solved, right? No. There's one thing I don't like. Can you spot it? There's the stupid sleep in there. That's like, polling, like, you know, you cannot really find a good time for that. If there's nothing going on, you're just making pointless queries all the time. And if there's lots of stuff going on, then you reduce the throughput because you're not catching up fast enough. But Postgres also has a solution for that. That's called listen notify. And listen notify is basically a publish subscribe channel on the data directly on Postgres that you can use to tell other Postgres connections about that something happened. So let's take a look. I didn't explain the kick method before, but if you remember, there's two methods we need to do. One is kick and one is listen. That's the kick. Kick is basically just put something in the queue in the database table, and before we didn't do anything after that, but now we also send a notification. So the send notification is just here, we fetch the database connection, and then we just do notify, and the channel name is probably something like the name of the model or whatever. Then we execute that, and cool. And the listen now also changed a bit. On the top now, we connect to the database, and then we issue a listen. And we listen for the same channel name. And now instead of the sleeping here, we're just stuck in this loop here, asking for notify. And whenever something new gets queued from the kick, we will get into this loop, and then we do it. And if there's 5 consumers, whoever is the first one to fetch this one I missed the select for update. Please ignore. This should usually have a select for update and skip blocked. Anyway, whoever is the first one will grab the right one out, and for all the other ones, we'll just see nothing, and we'll continue and then wait up here again. And yeah, that's pretty much it. Fully works. Well, there's lots of code, but there's some code missing, obviously, and we fixed that error. And yeah, that's it. So let's look at the message broker that we built. We have multiple queues. We allow multiple consumers per queue, multiple publishers. We can keep track of the messages. We can do it in a safe way. Queue management, monitoring, manipulation, all that is just CRUD. It's just create, read, update, delete. So that's easily doable. We're doing that all the time in web development, right? Persistent data storage, we constantly store everything, so we also need to find a way to clean it up probably. And are we optimized for high throughput? I don't know. So I checked, obviously I checked. So I ran some performance tests. Blue is RabbitMQ and red is our PG broker, and so the PG broker is consistently less throughput. In the worst case, 80%, and in the best case, 94% of the throughput. So we're pretty close, I would say. It turns out that the longer the request takes, the less weight is put on all the other crap the database does, right? Because the transaction management and all the things that are probably way more heavy in Postgres than in RabbitMQ, just because it does way more things. If the request takes 5 seconds, those few hundred milliseconds or this few milliseconds or tens of milliseconds that we add probably is not that important anymore. And if you ever used an LLM, like it's not like if you ask ChatGPT a question and in 10 milliseconds you have the answer, right? It's usually that it takes seconds and seconds and seconds of streaming the data. So this is actually totally working in our favor. Last slide, summary. So if you want to do that, select for updates keep locked and you're good. You also would probably need to add some indices, especially Postgres can do partial indices. So if you just do an index on all the ready messages, for example, this will even give you a better performance boost. You need to do some manual labor to get rid of old messages monitoring. That is obviously completely built in RabbitMQ or something else, right? So there is some manual work. Well, listen notify you can use to prevent polling, but there's one but. Every listener, of course, needs a persistent database connections. And if you're like dealing with databases in a regular fashion, you know that database connections are something that are kind of limited, or at least they are not unlimited, right? So it's something that you need to keep an eye on. But you can work around it. Actually, I have not merged my merge request today, but there is one waiting on GitLab just to click on merge. You can work around it. So what we did, for example, is I have a single listener that gets all the notifications, and then I just use Python queues, async IO queues, to basically wake up all the other tasks brokers. Anyway, so that can be worked around, I'm sure, in every language. Performance is worse, but for our thing, totally okay. And last thing I want to say, obviously we're not the first ones to come up with that. I think the biggest one probably is from Ruby on Rails. They have solid queue, which basically does the same thing. I don't think they do listen notify, I think they actually use polling. But apart from that, it's been out years and it's probably running very stable in thousands of Rails shops. And that was pretty much it for me. Do you have any questions? I don't know if you have time for questions or otherwise we'll see that.
Yes, we were quite quick, so we have some time for questions.
Hi, thanks for the great talk. I was wondering about the part around the persistence where you said no persistence with that solution, right? Because don't you get that kind of free if it's in a Postgres table? Could you just keep all of the messages in there?
So what I meant is that most of the brokers, so like RabbitMQ and Redis, if you use that, they usually don't store the. So I saw it as a feature that the stuff is not being stored. So if I use Postgres, I obviously need to do something to make it not be stored. So now, for example, we have now a cron job running that cleans up all the old tuples from the relation, because we don't really need them anymore, right? Like everything that the task created is stored in the real database, and everything that's flying around and is already processed, don't need it. So yeah, that was more meant in the way that you need to put in extra work if you want to get rid of all the stuff.
Got it, thanks.
Two questions. First, how big are your messages? And the second one is, with the listen notify, you still have all the processes going to the database and doing a query, so you don't get rid of that. Have I understood it?
Yeah. So yeah, the messages, it depends on the application. Sometimes it's just an ID. Sometimes it has a few megs, even if you put some binary data in. So far we haven't seen any problems with that. But that said, like also for RabbitMQ, for example, which is the only thing that I had really experience with, also with that, if you put in like messages with hundreds of megs, even RabbitMQ tends to struggle. So far we haven't had any issues. But yeah, good point. It's a potential problem. Yeah. The other question was what? Sorry.
With the listen notify, you still have many processes.
Yes, totally. Of course, because of the listen notify, you cannot pull the connection, right? Because it really needs the persistent connection. So it would make no sense to do any kind of connection pooling. So yeah, that is. I actually did like the last 2 days. I worked on removing that and replacing it with a single listen connection, and it reduced, in my case, it reduced like 20 or 30 persistent connections from the database, which obviously helps a lot. So yeah, it's probably, I mean, it always depends on the situation. If you have a dedicated database that only does the task management, then it probably doesn't matter again. If you share it with your normal database, then you probably want to do that. So it depends. But yeah, it's definitely a problem because the RabbitMQ is probably more optimized to keep up the connection than RabbitMQ, than Postgres.
At the beginning you said the reason you did this is for budgeting.
Mm-hmm.
Who is doing budgeting in this?
So we share those, we run these models, so these models are being run and coordinated by this manager, and all the applications, they basically need to get a fair share out of the costs that were allocated by building all these models and running all those models. And yeah, like I said, we need to fairly distribute it, and you can, the idea was that you get throttled down if you used up all your budget. So if nobody else is using it, you can still use it. Yeah. But if there's somebody else who hasn't expired all their budget, then they always come in first.
But is it the broker that's managing budgets, or?
No, our budgets are handled in this manager component, okay. And the manager component is using our broker to basically in-queue the jobs for the actual models from the applications on the front end. So it's a part of the manager component. Well,
there would be time for one more question, but if not, then we will hear the next talk about Lovable SaaS products. Thank you, and as a little gift, thank you. You get a sticker.
That was quite an entrance, but I now have your attention. So thank you guys for having us. Thanks also for the organizers. But I do want to thank the 3 English-only speakers, because else I would have felt pressured to have this presentation in German. So thank you for that. My presentation is not about the Lovable platform, because this is something that Martin thought my presentation is about. It's about how to have the highest impact through the code that you are developing. So more of how to build products that are lovable. A bit to myself, so I love building products and enabling teams to build great products. But beyond that, I love petting Snowy, the white dog that you can see here, photography and music. I play contrabass, piano, and sing opera. And my path wasn't straight to product development. I studied first electrical engineering, business, and then gradually went into product management. So I hope I can give you some insights that you would find useful today. I'm a Dynatrace, as you could have seen from the logo and the background. What I do is I lead a team that is responsible for experience from the product management side, not just from the UI UX side. And when I joined, I kind of realized that the product is very complex. So it is not a simple product that is just about one team that is having one goal and that's it. It's multiple teams having different goals, building different applications that serve different purposes for different personas. And we have so much as well in common that we need to optimize, ensure that this is cohesive, consistent, and offering a great user experience. So one thing that we worked on was basically how to ensure that when we move from the second-gen platform that you might be familiar with to the third-gen platform that is more modern, is about, like different apps and is cool, more open, and so on, that we actually ship more value and build a great experience, not isolated products that are not connected together. So it was basically my second month at Dynatrace when Bernd, our co-founder, tasked me with that and was like, what do I do now? Like, how can we work on that together? So one thing that we were basically thinking about was like 3 principles. So first of all, how can we focus on the outcome and not the output? How can we ensure that what we do is actually having impact by gathering a lot of input from the user and the customer, so to serve basically the customer who is the king? And how can we always evolve our product market fit? And with that, I will start with the first one. So, outcome, not output. I think it's clear to everyone, right? So it's not about just like running a new campaign or shipping this fancy feature. It's about how much can we achieve with that? How many marketing qualified leads, if you are in marketing, that you're actually generating? Not about how many campaigns do you run, or how much adoption are you getting, or how much is the performance getting better with the refactoring that you're doing, not just about how fancy and cooler the code is looking like. So this is all about outcome. Always think of the outcome. Don't even think about how cool or innovative the product would be with what you will be shipping. And with that, it was about this transformation. So when we first were looking at the roadmaps, it was like focusing on DQL or focusing on a particular feature in AppSec and so on and so forth. But it wasn't having this connected end-to-end value. So I do want to give you this example. You probably know this and have seen it in a lot of shops. So it's cute. When I had my firstborn, I was thinking I will get him one with planets because he should become an astronaut or something fancy when he grows. But I didn't think about what he will actually be seeing. So and I think this is honestly like the challenge of product development and user experience, is that we build things that we think are actually cool, but at the end of the day, how they are used and how they are perceived by the end user, this is something completely different, because we don't know how their environment is looking like. We don't know what is actually the thing that brought them to the product beforehand. So, like it could be that a user is very, very frustrated, then we get them to the chatbot and we say something that is not, like super relatable to them, and then they get confused. So we have to always think about, like what is really the emotion that the user is having when they enter the product and interact with our products. So to do that, it's about, like setting the goals of what do we have to do here. The baby has to go to sleep, like it's not that they need to interact with a cool toy at the beginning. And then we do discovery, how this is possible, and so on, and the delivery. And if we do that, for this case, it will be like a white noise machine that doesn't look fancy, but just provides the value that would make the baby go to sleep. So back to the business, what does it mean? So we all have fancy mission statements and strategic goals that we have to achieve. These are then broken down into business goals. We have to increase consumption by X% or boost the adoption in a particular area by X%. The one thing that we felt was missing was this layer here, like this end-to-end customer journey. So what does that mean then, this business value that we want them to go through in terms of value that they will be perceiving? And then comes the product roadmap. So I think that was really like the challenge, that we were first thinking about a lot of features and not this end-to-end perspective on a broader scale. I think this is really what enabled us. So an example, we have problem patterns, and the core, like of Dynatrace is that when a problem occurs, they can resolve it. So we built an end-to-end journey for that. An issue appears, the user is triaging the issue, they hand off, so it's probably like an SRE engineer who's first like encountering the problem, but then at some point they hand it off to a developer, they investigate the issue, and then there is the fix. It sounds simple. You cannot imagine how many teams are collaborating on this to make this happen. And here, making it end-to-end and thinking about it end-to-end in terms of the different problem patterns is really what can make the difference. So moving on from, like the first roadmap that I showed you, this is now how our roadmaps are looking like for the core end-to-end user journey. So we have clearly defined the personas. Here we have Ray, the SRE engineer. We have Dan, he's the software developer. These are the steps, and these are the core teams that are really like big teams who are working on these steps. I've hidden the roadmap itself because we have Perform coming up, so I don't want to reveal anything that I shouldn't reveal. But one thing that we did here was as well to put an estimation on when these things are going to happen, and I will tell you why this is also important. So first of all, we know now how is this connecting to the big picture? What does it mean, the VI that I'm working with in comparison to the big user journey? And then one thing that we did afterwards was to think about what are the core journeys that each solution is delivering. So that's an example, for instance, for software delivery. We have here the core personas and the core journeys that are important for these personas. What we did with that was to connect everything, all the content now that we have from all these teams into an LLM model that we call the user journey expert that I want to show you. So what we can see here, for instance, is core personas across Dynatrace, for instance, core journeys for the dev persona. This is from the landscape, but also it has access to our documentation, and it has access as well to a presentation that is, like guiding it. So we have like text that is giving it instructions, and the creativity level of this model is pretty low. So we wanted really to be fact-based and not to add any content that is not valid. But one thing that this is helping also our quality assurance team with is test cases and test scenarios. So because now we have also the estimated delivery date of these things, it's all automated. We can have test scenarios for the journeys that are related to the coming delivery cycle and ensure that this is all prioritized correctly, and we have also automated ways to navigate through that. So that was one thing that is helpful for like three things: onboarding new team members, finding intersects between teams and solutions, but also especially for testing. So the other thing is data. So before it was simple, like if you have like a restaurant or if you're selling a product, if users are loving it or not. But for a SaaS product, this is pretty hard, because it's not just depending on how good the product is. You have sales, you have different pricing models and pricing packages and so on. So what we do is that we really look at the data very deeply and different types of users. So paying users, trial users, internal users, and we make sure that especially also the product experience designers, but also developers, and also in that case we have also experienced PMs that are specialized on these end-to-end journeys, validate and interact with real users to ensure that this is the right thing. It's a learning process. It's not that we do it for everything, but for the core things and the core innovations, we try as much as possible to validate. We also watch a lot of user sessions to ensure that we're making the right decisions. And the last thing, especially like for Michaela, she's here, I was not planning to present this one, but because I thought everyone here is also like very techy and coming from a developer background, but apparently not. So one thing that is very important as well is not just to think about the product development silo and the users that are using it, because there is much more that is happening also beyond that. So, for instance, you have sales, you have C-level making decisions if the product should be used or not. That's why also we have business observability that is not necessarily, like the core of the business, but it's something that is very appealing to the C-level. We have competition, so we have to be super fast, support, sales, and so on and so forth. So we have to ensure that all these insights are coming in when we develop and define the product. So I would say for the product to be successful, we have to focus on the 3 layers: product, marketing, and sales. Each one of them is contributing almost like 1/3. It's not just how cool the product is, but how this all is about. So is there like an uncovered need? Is my feature that is very cool like hidden and not even like accessible or highlighted enough? Can we go to a new opportunity based on that because there's a growth opportunity that we don't see? How can we increase the retention rate is something that is also very interesting and is something that we need to evaluate. So not just how many used it once and that's it, but are they returning? Are they coming back? So all these KPIs need to be tracked on a regular basis. So in regards of this and taking all these insights in and evolving and everything that is happening now in the technology with AI engineering and so on, I think really there's so much that we still don't know, but those who are ready to evolve and learn and be like in sessions, I think like here to hear something new, are those who are going to survive. And this makes me think about, like the whale. So it's the biggest animal on the planet, but it's not, it hasn't always been there. So it's actually coming from a medium-sized like mammal, like the Pachycetus. And it has evolved because it was looking for food in the water and taking like a leap of faith, going more in the water, until it became the whale over millions of years. So with that, I would say, stay hungry, keep experimenting, keep learning, and developing. So be the whale. Thank you.
Thank you. Are there any questions? We have quite some time for questions.
Hi.
Hello.
You talked about customer journeys.
Yes.
And have you faced the problem when you have multiple customer journeys? There are sometimes the same stuff that's modeled multiple times. Do you have a solution for that?
Yes. So that was something that we realized is happening more than we thought, but multiple teams were developing the same things in different ways. And I'd say this landscape overview of defining the focus of each solution and connecting it with the LLM model is something that helped us. So what we did was then to break this down into a pyramid. So core journeys that should be aligned across teams and we know which one belongs to which. And then one layer below is scenarios. So let's say the problem journey we have, for instance, response rate analysis, we have failure rates and so on. So these are all like patterns and different variants of the problem journey. And then we have tasks. Like for instance, alerts, that's a task that happens across different ones. And these we try to ensure to have standards for so that they are consistent. So through this breakdown of these 3 layers, we are also developing experience standards that we ship across to ensure that this problem doesn't occur. And we gradually improve and learn throughout this process. But great question, thank you.
Right in the back.
Hi, thank you.
Hello.
My question is referring to You mentioned serve the customer, right? And make sure that the customer is happy. But this also means you're closely watching the customer every step he does. And what are you doing to protect their privacy or even the privacy between users? And the Dynatrace agents have like really intimate knowledge about the user system. So you have some scenarios where you particularly look at protecting their data.
Yes. Good question. The data itself is masked, so we don't see private information of the user, and we don't do it per user and customer, more than defining goals for the journey and ensuring that these goals are met. So, for instance, you have journey of 5 steps to see then through the journey mapping and the data, is this really what the user and customer is doing? So the majority of users overall, through, for instance, we have like an app called Product Analytics that we and also our users and customers can use. This helps us do funnel analysis. And through that, we understand if this is the path or not. But I think the one thing that is important is not just like checking the data and looking at what is there, but speaking to the user and to the customer to see if what we are planning to build and what we have in the roadmap is actually making sense. So I think early validation and talking to the user beforehand adds way more value than checking afterwards how is this being used.
Any more questions?
In the front.
Right in the front. I'm
Can I wait
walking.
for the mic? It's just kind of a follow-up question about, I'm wondering how responsive are customers and how open to taking a survey or something like that? Because you got those YouTube prompts like, oh, answer this one simple question. But I'm like, no, why should I do that? What's in it for me? So I'm just wondering, how much data do you get from customers? How open are they to, give feedback? And how do you make sure, almost scientifically, that it is representing, the actual, reality of things?
Really good question. Yeah, I think pop-ups don't work, and everyone hates them. So we don't put any pop-up. What we do is to link to the community, so they can then voice their concerns and the PM response, but not so many people also proactively do it. I think the best way is to connect with the sales team and the sales engineers in that case, so that you can have a close touch with the customer because they already have a one-to-one connection with them. So through that, I think it's really easy then to gain access to them. But scientifically, it's a hard question. I think one way to do it is A/B testing, but yeah, we don't do enough of them, I'd say. But I think this is the only way to really assess if variant A or B is working better.
Okay, thank you. You also get a sticker as a thank you.
Thank you.
I think the speakers will stay around. If you got any questions, approach them. We will take a 45 minutes break now, so 8:15. I think the food is ready, drinks are ready. Enjoy. After the break, I will present to you the community news. Lots of other meetups are also really motivated this year, as you will see. Then we will have a third talk, and then afterwards we will have some more time for networking, at most until 11 p.m. But now enjoy the break. Welcome back. I hope you enjoyed the pause, the break. You had some beer, some food. Now let's have a look at the community news. There's a lot going on in the upcoming month. So today you made it to Technologieplauscherl number 90. Yay for you. Tomorrow there are 3 different events. So whatever topic you prefer. You can go to the .NET Stammtisch Linz at the Dynatrace, lab Linz, which is next to the JKU. If you're more into the Linux FOSS topic, you can also go to the JKU, but in the science park, so opposite of the street. Or if you're more interested in AI, you can go to the AI Stammtisch at the Otello. Next week, there's the first Cloud Native Linz this year, and the day after, there's the Women in AI, again at the JKU campus, at the ITU, basically also the same address, I think. At the end of January, if you want to visit another country, there's the Vorstellung in Brussels. It's a free conference. You can just go there. In February, again, there's a Linux user group in Wales. Or on the same day, there's a platform engineering in Linz at Dynatrace. Dynatrace again, but this time with the 25er tour. .NET Stammtisch is very motivated this year. They also already announced their second event on the 24th of February. And on the 28th, there's the code retreat, where we will now hear something from an organizer.
So, we're doing the code retreat on the 28th of February in the Linz Wissensturm. Who of you have ever been to a code retreat? It's Christian. Thank you. We would like to have more hands next year when you come here. So please join us. What are we doing? We are coding, but it's only for practice. We will delete the code afterwards, and it's not going to be any useful outcome, but you do practice. What do you need to know for the code retreat? You should know a programming language and an IDE. You don't need to know a lot more or a specific language. You should have unit tests or a way to do unit tests. And, well, we will provide free food, free coffee, and a great day. And we hope a lot of you joining. And it's completely free. Just sign up, and it's linked in the site here. And ask me if you have any further questions. Yeah, thanks, and hope to see some of you.
Thank you. The Valug is a monthly meetup, already announced their date for March. It's the 12th of March, also in the Alte Schlachthof at Wels. If you made it here, you can also make it to the NX AI office. It's also in the Tabakfabrik. On the 12th of March, we will have an AI ball and talk about industrial AI. And I'm really happy to announce the next date for Technologieplauscherl. We will try something new and visit a school. It's the HTL where I went to. It's the HTL Paul Hahn. You can go there by the bus line 43 and 46, I think. So yeah, I hope to see as many people there as are here today. And then the last entry is the at the end of May, the RubyConf. We still have some tickets, so please, after the third talk, come to me and yeah. With this, I will hand over to our next speaker. We will hear something about logistics, Kubernetes, and gitops.
Thank you. Hey, so working now. Before I begin, a quick, I'm sorry, a little bit. I got the information that Technologieplauscherl is
looking for speakers, and I thought, hey, I have something from the OpenShift user group, I can get started with this one. Then noticed, crap, it's half the time in here in an audience that I'm not sure what to know of Kubernetes and of OpenShift, so I had to redo a lot. I got the time slot of half an hour. I also got the information that as I'm the last speaker, it doesn't matter that much if you're gonna take a little bit more, but we're gonna see. What to expect today. So this is not about any best practices on how to, on what you can use with Kubernetes, what you can do in there. It doesn't go very deep from a technical point of view. I'm just going to try to show some of the challenges and environments we're working in, how we try to mitigate it, and how to work through it. If any questions come up, if you're not following, just raise your hand, shout out. If there are quick questions, I'm going to try to answer in line. Worst case, big questions, going to put to the end. A little bit about me. I'm a software architect at TGW. We are in Wales. And I have a strong background in .NET. For many, many years I was working in the .NET library development, going more into build infrastructure and deployment topics, and migrating to our entire code stack to Git. And at some point in time this led to this project, which internally was called ADP, the Advanced Deployment Platform, which eventually introduced OpenShift. So what we're doing, and this is not to be advertising ourselves, this is just for you to get the picture. We're building warehouses with millions of crates and hundreds of devices. And we don't have just one warehouse running, we have hundreds of warehouses. Chances are pretty good if you are shopping at an online retailer, it goes through one of our warehouses. Or if you're using from regular shop vendors, from retailers that have their warehouses to restock their different sites. And in there we have to communicate with a shitload of devices. And a single device can be such an entire storage rack where the crane is running around and grabbing the right pockets. This can be a shuttle block where we have the different shuttles and need to control the shuttles very granularly. They have to go back to the lift, drive up one level and go to another location. A single device can be a conveyor, a single device can be a robot driving around, or a palletizer that automatically stacks a pallet, or a depalletizer that unstacks it again. It can also be a big station where a worker is pretty much standing the whole day, pick 2 items from the left and pick 50 grams from the right hand and put it in this box, and the box drives away to end up the palletizer somewhere else again. Depending on customer needs, we usually deliver everything from ground up. So each site is scaled to specific customer demands and says, I want to restock 50 sites, I want to send out my online store orders. And each customer is unique, so everyone is working a little bit different. Of course though, standardization is a big factor. If you want to go somewhere, it's not that the complete warehouse control and material flow system is developed from scratch again. The workload we are running in our warehouses is usually rather static. We have our peak times with Black Friday to Christmas around this one. Then we have the peak one, and this is the time where the big money is coming in, so everyone is super concerned. So it can be that from October onwards we're not allowed to make any major updates. Definitely no. It can also be that we can't even ship bug fixes because the customer is saying, yeah, this bug happens in this situation, in this case, and I have 50 workers knowing how to deal with this bug. Don't not push out any new updates. In general, our software needs to be able to run entirely air-gapped. When we got requests from customers, the air-gapped and connectivity is often very, very high. During customer discussions, though, it's usually up for debate a bit. In the end, what the customer wants to have is, they don't care that much if you're air-gapped or not. In the last 15 years, I've been in this air-gapped discussion, I think 100 times, and I know 0 sites that actually run air-gapped. But the customer wants to be in control of what his warehouse is doing, that is not some side injection or something like this, or the internet connectivity goes out. We have warehouses sitting in very, very rural area in Poland, in the USA or something like this, where you have crappy internet connections, where you can't control your warehouse from the outside. And many, not all, many of those devices and software components we have in there are time critical. With those time constraints, we are usually required to run within the customer's warehouse. So the customer builds this huge warehouse. We have our data rooms, our data centers, small data centers, but data centers nevertheless, with 2 fault domains, 3 fault domains, however money the customer wants to throw in. From latency point of view, this is often, the boxes are running, for example, on a conveyor, and we need to decide, go left or right, go up or down, or something like this. And sometimes it's in the 20 to 30 milliseconds that we have for messages to come in and to respond. And in those 20 to 30 milliseconds, we need to go on through our entire software stack. How we came to Kubernetes and OpenShift. So back in 2022, it was very obvious that all of the software components need to work together smoothly and tightly so we can achieve our transports and our rates and our peak rates and so on. But what wasn't obvious for a very, very long time, all of those different components should work in a rather similar way. And they should have a similar deployment path and to ship it out into sites. The basic software products are developed by different teams. We have Java development teams, we have .NET development teams, different program languages, different frameworks. Back then, different build environments. Some were building in Azure DevOps, some in Jenkins, and some with self-written tools. Yeah, because we are some kind of legacy stack, and 15 years ago, Azure DevOps wasn't that big deal, so somebody came in, yeah, I'm going to automate MS Build in some way and write the UI on it. From order of magnitude, we have around 10 development teams with 100 developers, mostly sitting in Austria and Germany. Mostly, in general, single individual ones sitting worldwide. The product teams don't ship the software directly to the customer or directly to site. Our customers, from product development point of view, are different TGW units. The units that are sitting in Germany or in the US or in the UK, they are the ones that actually selling to customers. So we ship to them. Some parts of our components only need configuration. I need to have 15 instances here and there, but some parts also need heavy customization. This means that we have custom Java code, custom .NET code, custom database code, and so on. Realization teams are not the experts, the deep technical experts on each and every technology. They have to integrate a shitload of technical stack, from RabbitMQ to the products, how the messages are being sent through, to authentication and so on. And from order of magnitude, we have around 200 plus developers in ever-changing teams, because every new customer project comes in, 1, 2, sometimes maybe 3, 4, 5 teams come in. And when the customer project is done, when we have the sign-off, it's handed over to the LTS department, they take over and the teams focus on new projects. So each and every time one of those 300 plus developers needs a new test environment, this meant provisioning 3 to 5 virtual machines, installing all the required components, hitting off the build pipelines, installing all the cross-functional services, and configure all of those. You have the authentication service, in our case KeyCloak, you have the OLC redirect URLs, you need to go through lots of files. We got complaints from our customers, from other TGW guys with, hey, your system is insane, I wanted to have a new test environment. One of my best guys is now working on this one and it's already taking a week and he's not done yet. So more often than not, embarrassing as it is, it's, hey, you had a customer environment, a test environment, do you need those virtual machines, can I grab them? So they were being reused, it was unsure what's actually going on in there, what was deployed. Bugs were reported and they had to be declined because it was crappy configuration in the first place. And each and every time you wanted to bring a new version to this, it meant connecting over RDP or SSH to it, stopping the services, installing, starting the services in the right order again, and all of this to continue. Roughly at the same time, we were already consolidating everything to Git and Azure DevOps. Some components were already completely there, some had it on their roadmaps. What was entirely unclear to us, how do we want to ship the software on to sites? The current state, we can't continue this one anymore, it's just from an effort point of view, it's too much. How do we want to update our software? How do we want to patch it? And what kind of system do we take for this one? In the end, we are a logistics company. We don't want to invest our time in writing our TGW software deployment center or something like this. So we had to find. It was rather soon with, we're gonna head to containers. We gave out, it sounds harsh, but we gave out the order to the teams. Hey, we need to have everything containerized. Java pretty much was there. .NET was a little bit more crappy. We were mostly on .NET 4.8, so we had to upgrade to .NET Core. And .NET Core upgrades, we had 15 years of technical debt in there with from layering, slicing, dependency hell. We pretty much from IOC point of view had to turn our applications around. We shied away from it, from Kubernetes in the first place. It was, it's too complex, we don't want to deal with this one, we don't want to have it. But Kubernetes pretty much came up as our top contender rather soon. The big up and downside of Kubernetes, the ecosystem is huge. You have different container runtimes. You have Kubernetes at heart is just a library. It's pretty much just a library that you can use, but in effect it's not usable. You need an operating system, you need ingress, you need the container runtimes and all of it. And then we were, okay, we don't want to build anything ourselves. I don't think we can manage of integrating all of this stuff together so we can have something that is actually usable. Rather soon, we're not doing this ourselves, we need a Kubernetes distribution. So from Kubernetes being just the engine, and I'm sorry, this is almost a sales slide, I got it from Reddit. You can have the individual parts, and in our case we went to the self-managed Red Hat OpenShift, which pretty much here's the ISO and install it, and it brings the operating system and all of the functionality in there. You can also go to some kind like AWS or Arrow and run OpenShift in there, but we have the networking connectivity requirements, so this was not an option for us. In the end, decided on OpenShift as Kubernetes distribution. We got the patching and upgrading and integration down to the operating system level. We got a shitload of training materials. We had the internal DNS, certificate offloading, and all of this. We also made one exception. The Oracle database remains as is. So the Oracle database till now is still running in virtual machines. This is on the one hand technical point of view. There are some parts in Kubernetes like storage access that can be tricky. And in the end, the Oracle database and the data inside, those are our ground rules. If you have a warehouse with, say, 1 million boxes in there and you lose the inventory, companies go bankrupt and yeah. So OpenShift was set for us. The next step was we needed to find some way on how we utilize OpenShift. What we didn't want to have is a gitops deployment. The engineers sit in there and say, okay, now I want to install this and install this and install that. This is not reliable staging process and so on, or crap, this doesn't work. So we rather soon settled, we need to have a gitops deployment, or we wanted a gitops deployment. So pretty much everything. Do you guys know gitops, what it's roughly about? Yeah. So we're committing everything to a Git repository, then we have Argo CD running, and Argo CD is reading from the Git repo and pretty much stupidly applying it to Kubernetes and sending it over there. It took us a while until we had, already got the first 15-minute warning. And for the GitOps layout, we had some rough outlines and estimates on what we wanted to have from there. The GitOps pattern that are usually available more focus on web development. You run a web shop and you have it in there, but in our case we have hundreds of sites, we have 10 to 15 years maintenance cycles, what we need to be available, so it doesn't work for us. We wanted to have new deliveries to customer environments, they can be staged. So we need to be able to bring it to a test environment first. And when we want to publish this one to production, we don't want to have a rebuild in between. None of our clusters are reachable from the internet. They can reach outside, but they don't have any inbound connectivity. And we don't want to push into customer environments. For us, it was the mantra, the customer is in control, the customer can cut the firewall connectivity and so on. Everything will remain working. And we can talk to the customer, hey, you are always in control, you can cut everything, and your system is connecting out and checking for updates, and you can pretty much close those connections. And the layout had to be easy to understand for hundreds of people. In the end, we came to picture something like this. It seems scary right now, we're going to walk through the details later on. So we pretty much have our Git repository with our software releases in there. The customer projects clone it in. The customer projects run pipelines. They are stored in a GitOps repository per customer. And then we have the different OpenShift environments where Argo CD is connecting to those GitOps repos. Let's kind of take a closer look on how we actually doing this and how this one works. It's going to be a real deep dive. Use case for this one is this IK project, and IK is pretty much the Swedish version of Spar or of Coop or something like this. Each of our warehouses, each of our projects have a dedicated Azure DevOps project. And in those Azure DevOps projects, each and every component has its own repository in there. And besides those component-specific repos, we have two magic repos in addition. One is this ADP cluster config, which in perfect GitOps style contains all the cluster configuration from security to permissions, security settings, resource groups, and all of this crap. And on the other hand, we have the GitOps repo containing the Kubernetes definitions for the actual application. If a new project starts, if for example this IK project starts, they can go to one magic Azure DevOps project we have, which is a self-service project, and they can go in there and say, I want to go to the Northern Europe organization, I want to create a new group, and they can pick the components that they want to have in from the different versions, and click run. The projects are being set up, the components are being cloned in, pipelines are being set up, permissions are being set up, branch policies, and all of this stuff. After around 10 minutes, everything is set up, standardized in a picture-perfect way. We're not shipping binaries to our customers, to our units. So in those repos, we have Azure DevOps pipelines, we have complete Java and .NET solutions that we're shipping there. And we're using Git, directly Git, for much of our internal software delivery mechanisms. The GitOps repo is pretty much one large Helm chart. And at least the ones of you that know what GitOps is likely also know what Helm is. Which is pretty much a templating engine where you can inject and replace variables. And almost everything that is running on-site is in this GitOps repo. The only notable exception, we don't have secrets in there. The Oracle database connection string, for example, if you need to connect to some kind of outside service where you need to have permissions, those are stored directly in OpenShift, in Kubernetes, but we don't have this in source control. The GitOps repo is not manipulated directly. It should, at least for production environments, for production branches, no developer should connect directly to the Git repo, make commits in there. This should always happen through pipelines. But here we had the problem again. If now 10 development teams would start setting up their own pipelines, running their own templates and so on, we would run into some kind of configuration drift again. Works here, works there, works a little bit different, has bugs, the bug is already fixed. So what we did, we're pretty much templating the pipelines. We have this, in our case it's called build core, that we make available to all the different component teams. We have the Git repository in there, where the pipeline code is in there, that they can clone into their components, and afterwards they can pretty much just, those are my build step, I need to calculate the version, I need to run PowerShell codes, the NuGet stuff, and the container builds afterwards. This helped us to have a consistent experience to our units, so each and every component, at least from starting point of view, works the same. Writing Kubernetes resource is not rocket science. But if you're new to Kubernetes or if you're unexperienced in it, it can be rather scary. If you take a look at how pods should be co-located, if they should be placed near enough or not to avoid unnecessary network traffic and so on, this can be hard to get started. And on this one as well, the pattern should remain the same. So the 100 developers, they're not the Kubernetes experts. They should know how to use it, how to apply it, but we have a small team that should know Kubernetes or do know Kubernetes and OpenShift in more depth. They evaluate features, they write architecture constraints, or at least in our case it's called architecture constraints, of how something should be used. We give them out a preview and say, hey, we want to have this pattern in there, and they should apply and follow it. They don't have to apply. They can make exceptions, say, hey, the pattern you sent out works for us, doesn't work for us, or in the best case, the pattern you sent out is crap, I have a better idea. Then we can make the review process again, bring out the new architecture constraint, and we have consistent experience again. In some cases, with our pipeline implementation, we can also extend Kubernetes functionality. Kubernetes has usually horizontal scaling. You can run 20 pods in parallel, and each one of them is pretty much of the same value. You don't get any guarantees of which one the traffic or the requests are actually routed to. But here again, we have, for example, 14 palletizer instances. We don't want to configure palletizer 14 times. In this case, it doesn't even have to be the 100 rather skilled product developers that can focus a little bit or can spend a little bit more time on such features. We're now talking about the 200 plus realization engineers that have to integrate everything together. So we made some additional features in our pipelines, which meant all of those palletizer 1 to 14 instances actually are coming from a single source. So we have this _n, in our case, suffix, which for our build pipeline means, yeah, we have a multi-instance component, we check the configuration then during loading, during pipeline run, and say, okay, we got the named instance palletizer 1, 2, 3, 4, and we expand and explode this. In our GitOps repository, we have multiple branches, and each branch in there can be executed in multiple environments. So it can happen for us. A customer is running the production branch in production environment. We get the ticket and say, hey, we have this functionality in there. We're running into this bug, and I can go in there and say, okay, I want to clone this. I want to run this production branch in our in-house environment and have it available there. This also means within our GitOps repository, we can't have any information of what are the cluster URLs. Is this a production environment or a pre-prod environment? And for this, we have lots of different Helm variables in there that we're using, which are again perfectly fine described in architecture constraints, so each and everyone can use them. In production environments, those values are set up through this ADP cluster config, this Argo CD app of apps, where we can pass through such information that are being determined during the installation phase. Where we say, okay, this cluster is the 325.678.tgwgroup.site, and we're injecting this. And during our deployment process, we're actually installing and configuring everything from the keycloak authentication server, the configuration is being applied via Terraform, the OAuth redirect URLs are being set and injected, the Nginx reverse proxies are being configured, and we can automate now all of this. So how does the deployment now actually look like for us? The first step of deployment is always going to the components, which is now within the realization project, and running the delivery pipeline. On the top right corner, you can see from which branch you want to execute this pipeline. So this can be depending on the branching model the team wants to have, if they want to have master-based or sprint-based or feature branches. You can select the branch in there. We then execute the pipeline, and then we need to commit the changes. The component-specific repository hosts the GitHub source definitions. Through the actual delivery pipeline, we copy it over into the gitops repository. The branch that you were starting on, for example, you started with feature A for one specific component. You can start the delivery pipeline from your feature A branch. The pipeline runs, it checks in the gitops repository, is there already a feature A branch? Yes. Okay, committing directly to it and pushing to this one. If the branch doesn't exist, it takes a configurable base version, which can be master or it's the Git default branch that is configured, and we start from there. If the branch has branch protection, so it should enforce a pull request workflow, we're pushing to a temporary branch and opening up the pull request. And then we can see, 5 minutes, it's going to work out. And then we can see what's the new version that's being pushed. We never ever have tags like latest or release or something like this. We only have one tagging strategy, which is writing down a 4-digit version number, major, minor, patch, plus build ID. So we're actually deploying very specific builds, not giving me the latest one, but giving me this exact build. This is what we have in our GitHub repository committed. As soon as this pull request is committed, the Argo CD the Argo CD application shows up is out of sync. Argo CD can be configured in multiple different ways. It can have an auto-sync. In case of auto-sync, it's pretty much assumed, hey, in the GitHub repository, there's new code in there, I'm gonna apply this straight to production or wherever it runs. And you can also configure a self-healing. And self-healing is pretty much avoiding click-ops interruption. So if LTS service guy comes in there and says, oh, don't know what this one does, makes a change in the UI, then Argo CD comes back and says, oh no you don't, and is actually reverting this. For production environments, we recommend having autosync as well as self-healing enabled. Because having autosync and self-healing available is the only way to ensure that Git remains as the single source of truth for an environment. Part of the disaster recovery plan can be, if a meteor strikes and this specific data center is down and the servers are gone, I don't care, a new OpenShift installation takes 45 minutes, applying the configuration afterwards takes 10 minutes, you are done. I don't need to restore anything else if everything is in source code. If I click on this yellow out of sync, I can also get diff and Argo CD. And now Argo CD is actually diffing what is being applied in Kubernetes at the moment and what is in source control right now. At the moment, you only see those ugly hashes and versions and build information in there, what's actually differing. And our pipelines are going to be extended so we can see the complete Git log since the last commit that was applied to environment, what should happen there, and which actual changes are going to be applied. Clicking on sync in here, Argo CD is taking over, grabbing the Kubernetes definition, pushing it over into OpenShift, and afterwards OpenShift is taking over and is actually redeploying and starting the redeployment and rolling out the containers. So in that case, it was this SaaS configuration pod that is restarted again and is applying the latest Terraform configurations. As a side note, We also create SBOMs during the builds and place the SBOM files in the GitHub repo. On one hand, we have this highly structured cyclone.dx format, which we can use to run CVE scans. So we can have a pipeline in Azure DevOps, and in branch X, I want to get the actual CVE report at the moment. Pipeline runs through, and afterwards I get the report. My highest security rating or my highest CVE rating is a 6.5, yay, or is a 9.5 with crap. Besides the highly structured cyclone.dx, we also have a less structured proprietary format where we write the SBOM information again, which is pretty much just which application, which version, where it's being built from, what's the source code repo, what's the commit hash and the branch, and a shortened SBOM, a textual SBOM, which this is library ABC in version 1.2.3, library DEF in version 1.2.5. It doesn't bring anything from CV point of view, it doesn't have any hashes in there, but it's human readable. And those files are being exported or are being imported by our CMDB system. Which means if we have the deployment at 11 at night, at the next day in the morning, the complete CMDB system is updated again. What are my new binaries? What are the exact versions from source control, in which version, and which libraries do we have in there? So I could go to the CMDB system and say, where is log4j in version Y installed, and I get the complete list. This is available, or this is being installed right now on the following sites. The site we've seen before, looking like this, from an OpenShift point of view, it looks like this. So we have the different components grouped, we have the WM system, we have the portal, the UI front end, we have the authentication service with Postgres and so on, we have the Alpaca, we have the pelletizer instance, and it's running. When I showed this at the OpenShift user group, they were, hey, you're actually using this UI, I thought nobody was using this. And they were in the end completely right, because from a maintenance point of view, this UI is completely worthless. Nobody operating a cluster is going to take a look at this UI. From project management point of view, this UI was the best thing that ever happened. We had 20, 50 stakeholder discussion with, yeah, do we agree with Kubernetes, with containerization, but do we really need this? And yeah, is this really worth it? Then we had the first demo where we actually shipped those platform components with authentication and so on. And I could say, okay, now I'm running the pipeline. You can see nothing is installed right now, and this screen was black. And now I'm going to apply the changes that are coming in, and it was. And after 2 minutes, all of the deployments were there, all of the services were there. The users could actually see this one. They could see those tiny little arrows between them, how this interconnects and so on. And this UI alone sold our project to our internal stakeholders. From operating point of view, do we agree, completely worthless. From sales point of view, great. Just for the sake of completeness, on an overview, you also get the information in OpenShift, or this one is the OpenShift specific UI, on what's the actual CPU usage of one such environment. So this is a dev environment running pretty much idle, so all of the services that you've seen earlier are taking a third CPU and 10 gigabytes of RAM, rather functional dev environment, nothing running under loads, complete warehouse running on 0.3 CPUs. Idle functional tests. Comparing this to the status quo, so earlier I remarked the first deployment, or the 2022 state, was that it's going to take a week to set up a system. Afterwards it took 10 minutes. So all of this coming up takes 10 minutes. Yeah, perfect, it's the last slide. And those 10 minutes are not 10 minutes of working. This is less than 1 minute of working, and then sitting there waiting 9 minutes for the services to start up. From consolidation point of view, we have 120 environments running in-house in our dev environment, And those 120 environments that would have taken something in the order of 400 to 500 virtual machines, they are now running on 30 virtual machines. And it's not even each virtual machine has 24 cores. No, this is a virtual machine having 12 cores and I think 40 gigabytes of RAM. Yo, that's it. I'm in time. I'm in time.
Thanks, really interesting. Also the big scale. It's really nice to hear. Thank you. Are there any questions?
You were talking about horizontal scaling for your services, and I was wondering, are you using vertical scaling also, and how do you declare that for the rollout?
We do have horizontal scaling on some of the web frontends and web backends. They can scale horizontally. We do have the requests coming in at the moment. The 90% of our services, they are pretty much static. We don't need to have any dynamic scaling in there. But we have, for example, components that calculates pack plans. And this means the order, or let's say order for calculation is coming in. And this means we now need to scale out a lot. And this is something that we're currently investigating, and this is also in combination with hyperscalers. In the end, we want to run the vast majority on-site. The customers are more and more heading into the area that the data centers should be smaller. And we want to follow what the customer wants. Even if you have a small data center with only, say, 200 to 300 cores, prices are steep at the moment. And if we put everything in the data center, we need to place data centers, or we need to scale data centers rather high compared to our actual payload that we need for execution. So at the moment we're checking if we can, for example, based on RabbitMQ loads, scale out into Asia environments, so we can have 50 to 100 calculation instances running in Asia, scaling out, running for half an hour, and then we have the pack plans for the next couple of hours again, and they can scale in again. Unfortunately, no good answer at the moment, we're not doing it yet.
How do you deal with OpenShift updates? So how often do you doing these updates? Because Kubernetes typically doing 4 times a year. What is your plans, and are you doing this without downtimes, or what are your requirements from the customer side?
In OpenShift you can run updates to the control plane and updates to the worker nodes independently. So if there are, say, urgent security topics that we need to address sooner than later, we can pretty much always run the updates on the control plane while our operations are running. The updates on the worker nodes can be transient from an OpenShift point of view. Updates on the worker nodes cannot be transient from our application point of view. So we still have some services that take minutes to start up. And especially we have a few singletons left from application point of view that need to be refactored. Now we have the infrastructure so we can make those architectural changes. In those cases we say, okay, if something urgent is coming in, it usually affects the outer shell and not us. Our applications cannot be reached from the internet. We are running in corporate environments. We have, I don't know how many firewalls between us and the outside world, and we are running in the data center in one specific site. So the only devices that are actually connecting to us are from devices within the warehouse. Nevertheless, OpenShift updates are applied and can be applied inline. For application or for updates to the worker nodes, for this we need to discuss with the customer when we can have downtime windows, which can range from an hour to a few hours at the most. We usually, in customer environments, we run between 3 and 4 worker nodes. Does depend a little bit on the customer's resiliency requirements. If the customer is running 2 fault domains in the data center, we're running on 4 worker nodes. If the customer is running on 3 fault domains, we're running on 3 worker nodes. The less worker nodes, the faster the update is. This was kind of sidestepping your question, but leading into this one. I mentioned earlier that once production is starting, the projects are handed over from realization into LTS. And the LTS departments are encouraged, LTS lifetime services, the LTS departments are encouraged to run updates frequently. However, I still see sites that are running on 4.18. I can't force them, I can't put the gun to their head and say, do this now. In the end, they are the ones in contact with the customer. We can only urge them to do those updates. But in general, from in-house environments, our main dev environments, they are right now they're on 4.19. The 4.19 version is being end-of-lifed. The 4.20 is already being installed. We have an evaluation cluster where as soon as new minor updates come in, we run evaluation against our stack. If this one turns out fine, then we apply to our in-house dev environment. If it works in there for a specific period of time, we update the cluster configuration, say this version is now ready to be pushed to production. This usually happens within weeks.
Any more questions?
You mentioned that you have your Git repository on Asia for your customers. Do you have also a local copy on site in your local data centers and connecting Argo to this, or is Argo always connecting to the cloud's Git repository?
Argo is always connecting to the cloud repository at the moment. We had this air-gap deployment. We need to be able to do this on the requirements list, and we said, yeah, this is completely fine that we have this on the requirements list. We will deliver it when the first customer actually demands it. Talking about the air-gap, this usually there are 15 different versions of what air-gap means to 15 different customers. That's why we said, no, we don't do it. We don't do this at the moment. The first customer that actually will have air-gap will mean we're going to ship a Git repository there, and the Git repository can then either be manually synced, or they have some kind of service, or was also part of the discussion. We do have air-gap to our infrastructure, but we don't have air-gap to their infrastructure. So in that case, we wouldn't even need to have the Git repository on site, but we could use the customer's infrastructure. As soon as the first customer really has it and signs off on it, we're going to deliver it. But for now, we didn't have it.
And haven't you still the problem if Argo loses the connection to Git that Argo is doing some strange things?
No, never happened.
Okay, thanks.
One more question in front.
Great presentation, thank you. You also developed the robotics, right? That is related to the warehouse or just the software? Like, in terms of TGV as a company?
We deliver everything.
Right.
We have the metal, we have the metal factoring, we have the steelworks, we have the software.
That's very complex. So how do you align the releases of the hardware with the software?
On this one, I am particularly lucky because I can honestly and proudly say I have zero idea on this one. It's usually zero idea is maybe a strong word. So we get the sales guys saying we want to have, for example, the shuttles a couple of years ago. The shuttles need to have Wi-Fi connectivity, and this needs to be rolled out. So the shuttle development team starts, and then the project teams are being set up. With some guys from the component teams are coming in, and some guys from the mechanics teams coming in. They need to sync on this one. And at some point in time, we're going to have to release. Shuttle version 4 is now available, and this is supported starting with MFC 8 or something. From deployment point of view, as well as orchestration point of view of how the different components interact, it doesn't matter to us. And usually, such new hardware version that are going to be delivered or that are going to be created, they only affect one single component. So only a single team needs to interact and sync with one single device. But it's half knowledge from my side, sorry.
Klaus, thank you. Big applause. And a speaker for you. This means it's now time to stay around, network, get to know each other. And then I really hope to see you again in March at the HDL. We will announce the event on meetup.com again. Please register there. It really helps us to get enough food for everybody. And yeah, thanks for coming. Enjoy the evening.